Assalamu alaikum wa rahmatullah. This is the databases lecture, and let us start. So by the end of this lecture, you will be able to recognize database concepts, identify data types, define the characteristics of valuable information, and discuss the challenges associated with measuring and ensuring healthcare data quality. So why to study database? Database and data are important for informaticians. Who are the informaticians? They are uh, people who are responsible on obtaining and storing, organizing, and dealing with a lot of data to give useful information and improve the knowledge of their organization or a specific situation or condition. So whenever you are collecting data, storing data, and analyzing the data for decision-making purposes, we can call you informaticians. This data can it can be clinical data, cost data, inventory data, utility data, and any type of data. Based on the data and the information that we got from the collected data, we can identify areas of improvement for care delivery or guidelines practice, or even the individual patient level. Also, this data is used to standardize administrative processes, boost quality of care, and save a lot of time and money. And to deliver effective and efficient healthcare, we or you as a healthcare professionals will depend on accessing to accurate and timely data. So the healthcare professionals, you will be collecting data about your patients or the patient that you will deal with them, inshallah, and use that data in several ways to treat the patients more efficiently and effectively. So the physician will use the data to diagnostic purposes, and the pharmacist, they will use the collected data and the information and their knowledge about the patient condition to prescribe the best medication and so on. So health plans use data to correlate patterns of treatment with outcomes to generate improvements for individuals or populations. By analyzing data from thousands of patient records, the data can be categorized by type and stage of disease, medications, as well as identifying the geographic locations of the patient, the age, the gender, the weight, and other factors. And all of this data will give us useful information to predict the prognosis for particular patients, or to predict therapies most likely to succeed under specific conditions. So informaticians need to know how the data is stored in computerized version, and this is why we need to study databases in this lecture. Now, what is data? Data in simple words can be facts related to any object. For example, name, age, height, which are data related to a specific individual. Now, what is a database. Database is a collection of data. If you think about it now, databases are all over the place. For example, banks, they are collecting data about their customers and every transaction they make and store it in into a database. Let us focus now on the broader picture of a database system, which includes these four components. So here we can see the relationships between the four components of a database system. On the top, we see users. Now the users, they are people just like me or you who might need or use the data in a database. And then we have the application. So the users will interact with the applications, and these are programs that rely on the database. So physicians will use electronic health records program. Also, the physician can use the order program, and other programs can be used by administrative users and other health staff. So we have applications, and the end users will use or interact with these applications. These applications will rely on the database or will use the database, and the applications will talk to the database through the database management system. So the database management system acts as a gatekeeper. All of the information flowing in or out of the database must travel through the database management system. So users or application will not allow to directly access the data in the database. They need a database management system to do that. And then finally, far over here uh, on the bottom, uh, we can see the database itself, and this is where the raw data will be stored in separate tables. Again, database is collection of data organized. The keyword here is organized in a manner allows that allows access, retrieval, and use of that data. So the databases allow data to be stored and accessed quickly and easily. So what can a database be used for? You can think about the database as an electronic filing cabinet. So it can be useful for holding and entering and searching information such as patient records. And database has many types of models, but in this lecture we will focus on one famous type. It's called relational database. So relational database model. In this model, the data is organized in two-dimensional tables, and the relationship is maintained by storing a common field. So the table consists of rows or records and columns or fields. Each row has a unique key, and each column has a unique name. How is data organized in relational database? The data is organized in layers. So first, let us start with the character. The character is 1 byte. The character can be number or letter or space or punctuation mark or symbol. So for example, here the name Ali is consists of 3 characters. 3 characters. A is character, L is character, and I is the third character. The characters will be related and they will combine the name of a person, so they will combine the field. They will combine the field. So the field is a combination of one or more related characters, and it's the smallest data to access. Each field will has a name, it will has a field size, and it will have uh, a data type. Any database needs to be well defined and well structured, and to achieve that we need to define data types for each data. So the data type is an attribute that specifies the type of data that an object can hold, and it also specifies how many bytes each data type takes up. So here we find, or we can see, the common data types, which include text. So this type of data is used to store alphanumeric values like alphabets, as well as numbers and special characters. It can take up to 255 characters. Number stores different types of numeric data, numbers or decimals. Auto number, it will generate a number incremented by 1 automatically. So whenever a new record is added to the table, the number will be generated automatically. Currency, it's used for currency values. Date is used to store date and time. Memo to store text or combinations of text and numbers. Yes or no, it will take yes and no values, and fields that contain only one of two values, such as yes or no, true or false, on or off. Hyperlink, text or combinations of text and numbers stored as text and used as a hyperlink address. So it can be used to store website address or email. The objects can store pictures, audio, video, and attachments is used to store files such as documents, and multiple files can be attached to the record. After the character and the field, we come to the record. The record is a group of related fields. So for example, here you can see that we have multiple fields, and these fields consist data data about a specific student. All of these data are related to the student Ali. So we have here his ID, his name, the gender, and the major. And the primary key is the field that uniquely identifies each record. So the ID will be used as a primary key because it's a unique field that will not be repeated or duplicated. So you will not have another student with the same ID. Therefore, we use this field as a primary key. For example, you as a student, you will use your ID to access your or the if we want to search about a specific student, we can use his ID. Or if you go to the hospital, the hospital patient database will use the medical record number as a primary key. After the record, we have the table. The table is a collection of related records. So we will create table to save or to store the data about related records. So for example, here we have each record has data. Each record has data about student. So all of the data here are student data. So this is the relationship between the records. All of them, they are student, and the multiple related records will make the table. So we have here, this is a record, and this is a record, and this we have here a record. The key field or the primary key will be the ID, the student ID, and we have multiple fields. And at the end, the bunch of tables will form a database. So the collection of related tables will make the database. Databases are not just a bunch of tables. They are related tables. So the database also will include relationships between the different tables. For example, here we have the customers table, which will include customers records or records about the customers. So we have in the customers table, there is a customer ID, the customer first name, the customer last name, and the address. And we have another table for the products, and the products table has three fields: the product ID, the description, and the cost of the product. Then we have the orders. So in the orders table, we have four fields. We have the order ID, and we have the customer ID. So we will get the customer ID from the customers table, and we will create a relationship between these two fields. And also we will get the product ID, and we will relate it with the product ID from the products table. And in this way, we created a relationships between the products table and the orders, and the customers table and the orders. Why we create relationships? because we don't want to duplicate the information or the data again. So we don't want to duplicate the data or the customers about the data in the orders table. We will use the customer ID, and through the customer ID we can return to the customer data from the customers table. Now we are going to look into some of the databases benefits. So here we have a list of the benefits. We will start with reduced data redundancy. So by using databases, we make sure that the same copy of data is not stored in the same table or in multiple tables. So it makes sure that the data is stored only once, not redundant. There will be no duplication of the data. Then the second item, improved data integrity. So we can improve the data integrity by having restrictions and rules on the data to make sure to verify the data and validate the data. The third item is shared data. So sharing data will facilitate that multiple applications or software will use the same data with less development and maintenance time. Easier access, so the database will be accessed by any authorized users. So any authorized user can view, share, and access the data from different locations anytime using different devices. Reduced the development time. So if there is any change in one of the data, we can update the data with the new changes and modify the data just one time. The database software, often called a database management system, it's a collection of programs that manages database structure and controls access to data. It's possible to share the data among multiple applications or users and makes the data management more efficient and effective. So by using the database management system, it allows users to do the following: to create a computerized database, add, modify, and delete data, sort and retrieve data, create forms and reports from the data. We have different examples of database management system. We have Oracle, Microsoft Access, and we have MySQL. So the database management system is work as a gatekeeper between the database and the applications that will use the database. The purpose of the database management system is to control and manage the operations of the database. So here we come to the file maintenance, which is the procedures that keep data in the database current, and it can be done through these process or procedures: adding records, modifying records, or deleting records. By adding records, when you have a new data, you will add records to store this data, and if there is a wrong data or an old data need to be updated, we can use modify records to update the current data with an accurate data or with a new data. Deleting the records when the record is no longer needed, the user deletes it from the file or from the table. So here we will come to the characteristics of valuable information. The data we store should generate valuable information for the organization, because based on the valuable information, the decision makers will take decisions and design plans and implement the plans. So the valuable information should have the below characteristics. It should be accurate. So the information or the valuable information should be accurate, because accuracy is important. It should be an error-free, because, as we said, inaccurate data can lead to incorrect decisions. Based on the wrong data, it will lead us to wrong decisions. And the data should be verifiable, or the information should be verifiable. So the source of the information should be checked. Is it correct or incorrect? The valuable information should be timely. It should be delivered when needed, and the information must be on time for the purpose for which it is required. Because receiving information too late, it will be irrelevant. The information should be organized. So the presentation of the information is important to the user, and the complexity, the format, the detail, and the style of the presentation should be suitable to the targeted user. The information should be accessible, so it should be easily accessible by authorized users. Uh, it means that the information should be easy to obtain or access whenever it is needed. Useful. Uh, the information should contain all the important and relevant information, because unuseful information, it will be a waste in the space of the memory. Cost effective, it means that the information should be worthy. Any data should return a value, and the returned value should be more than the cost of the information production. How we can get valuable information? We can get valuable information by ensuring quality of data. To ensure the quality, the data must be managed correctly from the time of the collection until the time of analysis. The decision on what type to use is as important as the process as gathering the data itself. So gathering the data is very important, because based on this data, a decision will be made. And to ensure the quality of data, we can apply validation. The validation compares data with a set of rules or values to find out if the data entered or given is correct or not. Here we have types of validation rules. We have alphabetic numeric check, which will check from the entered data is it text or numeric according to the data type of the field. Range check, it will check if the data falls in a specific range. Completeness check, it will check if the field or the data is completed or not. And we have check digit. Here in this slide we have examples about the different types of validation rules. So we have the first validity check, the alphabetic check. So if we apply the alphabetic check on a field called first name, so the first name field will have a data of text. The data type of the field first name will be text. So if we entered the name Ahmed, AHMED, it will be considered valid data. But if we entered Ahmed with the letter with the number 7 uh, instead of H, here we will get an error to inform us that this data is invalid data. We need to enter text, not letter here. In the numeric check also, for example, if we have a phone number and the phone number type, data type will be number, and we entered here the number, this mobile number. It was a correct valid data. Uh, if we mistakenly entered the number with some letters, it will give us an error message that will inform us that this data is invalid, and we need to check it and re-enter the correct data or the valid data. The range check, so if we have an age field and we have a range between, for example, more than 18. So in the range check, we have if we have a range over 18 and we entered 19, it will be considered valid data. But if we entered 16, which is below the 18, here we will have invalid data because it's the 16 doesn't fall in the range of 18 or more. Completeness check. So if we apply the completeness check on a field called university name, and we want to enter data in this field, so we entered the university name, KSAUHS. Here it will be considered data, but if we left the field without data, here we will get error message, invalid data, because we need to complete this field and fill it with data. Check digit will usually check the accuracy of a given uniquely key value by adding extra digit to the key based on a specific formula. So if we have, for example, the ID, and also here we have security, social security number, how they can check if this ID is correct or not by using the check digit, which will use a specific formula to make sure that the data is valid or invalid. Also, it is used by the banks for the account numbers, the IBAN numbers, the credit card numbers, and the debit card. Each bank will have a specific formula, a check digit, to apply it on these data to make sure that the data is valid or invalid. Here we come into the entity relationship diagram. So the entity relationship diagram is a visual way of looking at your database structure. It is a specialized graphic that illustrates the interrelationships between entities in a relational database. The entities here will be the tables in the relational database. So think about the entity relationship diagram as a blueprint for your database before before you create the actual database. Um, so the entity relationship diagram is a conceptual model, and creating the actual database will be considered as a computational model. The ER diagrams often use symbols to represent three different types of information. The boxes will be commonly used to represent entities, which are tables. The diamonds are normally used to represent relationships, which are the lines between the tables that link between the tables. And the ovals, they are used to represent attributes. The ovals are the fields in the table. So here the symbols of the entity relationship diagram, the entity, which will represent the table in the database. So it's any object that exists in the real world. It has certain properties that is distinguished from other objects. So it tells you about something or somebody in the system. It's usually a noun, and it might be an adjective. So the object is a collection of things that share common properties or characteristics. For example, if we have a patient table, we can represent it as uh, uh, the entity patient in the uh, rectangle or the box, this rectangle shape or the box shape. The relationship, which are the links between the tables, they are the associations between two or more entities, so it link the entities. So for example, we can use the verb manage to make a relationship between the employees and the projects. So the employees, this is entity, and projects is another entity. To uh, link the employees and the object, we can use the verb manage to create a relationship between the two entities. So employees manage projects, and also we can use the verb work to link the employees with the objects, with the projects. So the employees will work in projects. The employees work in project. And we represent the relationship with diamond shape in the diagram. The attribute, the properties of entities and relationship, it means the fields in the table at the database. So each field we can use an attribute to represent the field in the ER diagram. For example, if we have the employee entity, we can describe it with the employee number, the name, the title, and the salary. And we represent the attribute with the oval shape in the ER diagram. We have types of attribute. We have single attribute, which will be represented by the oval shape. So if we have, for example, the student ID, it's a single attribute. We have multi-valued attribute, where we can have multiple values, multiple values for the attribute. We represent it with the double or duplicated oval shape, and the composite attribute, which is made up of more than one simple attributes. For example, the address attribute will be consist of uh, the apartment number, the street, the city, and the zip code. So we can use or represent the address with the large oval, and from the large oval we will have these small ovals for each uh, sub uh, attribute اللي هي الcomposite الاتريبيوت المتفرعة من الaddress. So we will have an apartment number here, and we have the street here and the city here, and we can have another one for the zip code. Also, we have types of relationships. Cardinality. We have one-to-one relationship where each instance of one entity class E1 can be associated with at most one instance of another entity class E2, and vice versa. At most means that one or less. One or less, it means 1 or 0. So to clarify the relationship, we can see the example. Each employee can work in at most one project, and each project employs at most one employee. It means that some of the employees will be working in one project for each of one of them, and some of the employee will not have any project, Also, at the project site, some of the project will employ uh, one employee, and the other of the project will employ 0 employee. And this is one-to-one relationship. Here, another example of the one-to-one relationship. So the relationship between the nuts and bolts is one-to-one because each nut will have a bolt, as you can see here. The second type of the relationships, one to many, one to m, or one to n. Here, each instance of the entity class E1 can be associated with 0 or more instances of another entity in class 2. But each instance of E2 can be associated with at most one instance of E2. So in the example, each employee can work in at most one project, and each project can employ many employees. So regarding this example, we can see here the diagram. Each employee, uh, work in at most one project. So they should be working on one project or less, and each project can employ many employees, and each project will employ many employees. So the relationship from the employee to the project is at most, it means 1. So each employee should be connected with one project or less, and each project will be connected with multiple employee because it's many employee. Okay, so the relationship here, the project the employee will be working on one project at most, so 1 or 0, and the project will be will employ many employees. So the n near the employee and the 1 near the project. Here we have another example of one-to-many relationship, the relationship between the owners and the pets. We have here a one-to-many relationship because each owner will have many pets and each pet will be owned by one owner. And here we have the many-to-many relationship where each instance of one entity class can be associated with many instances of another entity class and vice versa. Uh, to clarify it in the example, each employee can work in many projects and each project can employ many employees. So as you can see here, we have the project can employ many employees, and the employee can work in many projects. Another example of many-to-many relationship. Here, the relationship between the pets and the owners. So each pet can be owned by multiple owners, and the owners can own multiple pets. Also, we have uh, the types of participation. We have total participation and partial participation, which can be under the participation constraint. What does it mean, the total participation and the partial participation? So this represents how the entity is involved in the relation. If all the entity values are participating in any relation, then this relation is called total participation, and it can be represented by the double lines. And if only few values of the entity is part of the relation, then it is called partial participation, and it can be represented by the one line. For example, here, each student have to be member of at least one team. So all the students should participate in this relationship to be member of team. However, each student can be a leader of at most one team. So not all of the students will be leaders. Some of the students or few of the students will be leader of the team. So we represent it with the one line. The entity identifier, so one or more of the attributes that can uniquely identify each instance of a given entity type, we call it the entity identifier. For example, for the employee entity, we can use the attribute employee number as an entity identifier. And also for the project entity, we can use the project number as an entity identifier. It's like the primary key in the table. So to build an ERD entity relationship diagram, here we have some of the points you should consider while you are building the entity relationship diagram. First, to define the entity. So each table at your database will represent an entity, and these are usually nouns used in the description of the system and in the business and the discussion of business rules or in documentation, and will be identified in the narrative. Second, we need to define the relationships, and the relationship between the entities are usually verbs used in descriptions of system or in discussion of the business rules. So the relationship between the entities will be a verb, and it will be identified in the narrative. Add the attributes to the entities, the fields, and suggest the key or the identifiers. Which of the attributes will be used as a key identifier. Add cardinality and participation to the relationship, and represent that information with symbols in your diagram. So for example, we will use the following scenario to draw an ER diagram. So a house is identified by number. Each house also has a color and a three-part of address consisting of postcode, street, and city. A person is identified by social insurance number. Each person also has a name, age, and a gender. Any person lives in at most one house, and a house can have 0 or more persons living there. Each person may own 0 or more houses, and every house is owned by at least one person. So this is the scenario, and the required of you to draw the ER diagram. So we will apply the previous steps. The nouns will be considered as entities. So we have the house and we have the person. And the properties of the entities will be the attributes. So we have the social insurance number, the name, the age, the gender. And for the house, we have the number of the house, the color, and the address, which is a composite attribute. And then we have the relationship between the two entities. The person lives in at most one house, and the house can have 0 or more persons. So we have this is a relationship, and each person may own 0 or more houses, and every house is owned by at least one person. So this is another relationship. So here each entity, each now is represent an entity in a rectangle shape. So we have the person and we have the house, and each entity has attributes. We have for the person there is the gender, the age, the name, and the social insurance number, and the house has attributes, color, the house number, the address, which is a composite attribute, consists of the postcode, street, and city. The key identifiers for each entity: for the house number, so we underline it, and for the person, the social insurance number, we underline the social insurance number also. The relationship between the house and the person, represented by the verbs. So the first relationship is live in. So one house, at most one house, the person or any person will live in at most one house. So the relationship between the person and the house will be uh, uh, at most, that means one. Then the relationship between the house and the person will be the house can have 0 or more persons living in it. So the house can have many persons. So the M will be near to the person. Also, the other relationship, the own, which is a verb and represented by the diamond. Each person may own 0 or more. So each person can have 0 or more, many, and every house is owned by at least one person. So total participation from the house, because every house is owned by at least one person. There is a total participation in the relationship from the house side. So here we have another exercise where we have the following scenario, which represent hospital database requirements. Each doctor is described by doctor ID, multiple phones, and specialization. Each clinic is described by clinic number, name, number of doctors. Each patient is described by card number, name, address, and phone, and the relationships between the entities here. Uh, each patient is assigned to one or more clinic. Each doctor is allowed to work in only one clinic. So here we have the uh, diagram, the entity relationship diagram. We have the entity doctor, okay, and it represented or described by attributes, the doctor ID, the specialization, and multiple phones. So we have multi-value attribute. The doctor ID is the key identifier, so we underline it. Then we have the clinic entity, which is described by the clinic number, name, and number of doctors. And the clinic number is the key identifier, so we underline it. And we have the patient entity, which is described by the card number, name, address, and the phone. Then we have the relationships between the patient and the clinic. So each patient is assigned to one or more clinics. So each patient will be assigned to one or more clinics, to many clinics. So all the patient will be assigned to clinics. So this is a total participation. Each doctor is allowed to work in only one clinic. So each doctor will work in one clinic. So this is the relationship between the doctor and the clinic. Each doctor will work in one clinic. So the healthcare data quality is very important because in healthcare field, good public health decision making is dependent on accurate and timely statistics of the data. So it's very critical that quality of health data to be obtained in order to assess the magnitude and the distribution of the disease burden, so that programs can be developed and plans can be implemented to address the health needs worldwide. In a clinical setting, data quality is important because it can improve the care provided to the patient. Finally, we will discuss the challenges with measuring healthcare data quality. Since healthcare data is very important and sensitive because it deals with the patient or the human life and uh, health, we need to make sure that, or to ensure the quality of the healthcare data and to make sure that it is high. Uh, but there are some of the challenges associated with measuring and ensuring data quality and therefore valuable information. Yes. The first challenge is different interests. Which data to store? So if there is a patient was admitted to a hospital, the hospital has different departments. It has a department it has a clinical department and administrative department and financial department. Each department will be interested in specific data about the patient. So the uh, clinical department will be interested in or about the clinical data. What are the symptoms of the patient and when he was admitted and why. Uh, on the other hand, the financial department will be interested or more interested about the cost of the treatment of the patient. Then we have the second challenge, which is the information obtained can be accurate for one use, yet misleading for the other. So when we are using small sample data for generalization, can be misleading and it will lead to wrong results or findings because uh, in the healthcare data, you cannot generalize any findings without a huge amount of data. Much of the data is in multiple places, and in the healthcare settings, the data will be scattered in multiple places. This data need to be bring together if we want to make sure or ensure the quality of the healthcare. Inconsistent variable definitions. In the hospitals, we are using different systems, and the data will be in these different systems. Each system will has its own variable and definition. So there will be a different and inconsistent in the definition of the variables, which will uh, makes ensuring the healthcare data quality difficult because we will have different attributes at the different systems. For example, for the lab test, if you go to a hospital, uh, the lab test will have specific variables, and if you go to another hospital, the second hospital can have a different variable, and these different variables can be used by their lab system to analyze the data and the test. The data is complex, so some of the data will be complex, such as the text. So when the doctor enter um, uh, a note or document the information, the patient condition, to ensure the quality of the data, we need to have specific algorithms related to the natural language processing to process the text because text is difficult to computerize and to ensure the quality of the data. Changing regularity requirements, and this is especially in the healthcare settings. The health environment and healthcare is a very dynamic environment. It changes all the time, and the regularity need to be updated frequently to follow the changes, and this will make the ensuring the healthcare data quality difficult, because it's in this situation we require, or we need to have an update and modification all the time to follow the regularity requirements and the new guidelines practice, which is which are developed frequently. And here we come to the last slide. So thank you for listening.